Okay, first question. Find the integral from 1 to pi plus 1 of x times the cos of 1 minus x. Okay, this is a question that's either solved by an initial substitution, let t equal 1 minus x, and then go through all the substitution stuff, or you can immediately jump to integration by parts, which is what I'll do. So we're going to let u equal x, so du is equal to dx, and that means dv is equal to everything else. dv equals the cosine of 1 minus x dx. We integrate both sides to get v. Antiderivative of cos of x would be sine of x. Antiderivative of cos of 1 minus x is going to be negative sine of 1 minus x. And if you're not sure about that, you can do the integration explicitly and then do a substitution and then sub back. Okay, then according to integration by parts formula, this is equal to uv evaluated from 1 to pi plus 1 minus the integral from 1 to pi plus 1 of v du. I'll sub in all the ingredients we just found. So we have x for u, v is negative, the negative there, sine of 1 minus x, evaluated from 1 to pi plus 1, minus integral from 1 to pi plus 1 of v, which is negative sine of 1 minus x. I'll absorb the minus sign over there, outside the integral. And then du is dx. Okay, let's start subbing stuff in. Sub in the top bound of integration. We have minus pi plus 1 times the sine of 1 minus pi minus 1, carrying the negative sign through, placing x by pi plus 1. And then plus, we're subtracting the lower bound of integration, is already a minus sign, so it becomes plus 1 times the sine of 1 minus 1. So again, 1 for x for the lower bound. Now we have to worry about the integral. That's looking for the antiderivative of the sine of 1 minus x. Antiderivative of sine of x is negative cosine of x, but we have to worry about this 1 minus x. We're going to end up getting plus cos of 1 minus x, evaluated from 1 to pi plus 1. Okay, if you're not sure about that, you can do that again by direct substitution. Let t equal 1 minus x and go through all that process. Or take the derivative of the cos of 1 minus x and make sure you get this one back, which you do. The negatives, you get a negative from taking the derivative of cos, a negative from taking the derivative of the inside from the chain rule. Okay, so let's simplify this out. We're going to be getting a sine of negative pi. That's 0 here. We're going to get a sine of 0, and that's 0. That's good. Now let's sub in the bounds of integration to the next part of the function. We have the cos of 1 minus pi minus 1 again, and minus the cos of 1 minus 1. Okay, and then that's going to be equal to, we have the cosine of negative pi minus the cosine of 0. And that cosine is an even function, so cos of negative pi is the same as cos of positive pi minus cos of 0. And now we'll sub everything in. Cos of pi is negative 1. Cos of 0 is 1. It's being subtracted. So we get negative 2. Choice C. Okay. Next question, number 2. It's partial fractions decomposition. It's a nice one because it tells you what the form is. The x cubed in the bottom, that will have 3 linear terms, or 3 constant terms, a over x, b over x squared, c over x cubed, and then the irreducible quadratic, which you could confirm it's irreducible by calculating the discriminant b squared minus 4ac and finding that's negative. The irreducible quadratic is to the power 1, so it only has one factor, linear factor dx plus e. Okay, let's bring everything to a common denominator and then ignore the denominators afterwards. So we're going to have x plus 1 equals For the first term, we have to multiply top and bottom by x squared and by the quadratic. Squared plus x plus 1. And then for the second term, we have to multiply top and bottom by x. So b times x, and also multiply by the quadratic. For the next term, we have to multiply by just the quadratic. And then for the last term, the dx plus e term, we have to multiply by x cubed. Okay, now I'm going to use method 1, which was equating different powers of x, the coefficients in front of x to the 4, x cubed, x squared, x, and the constant stuff. We're equating left side with right side. So first we have to FOIL. We're going to get ax to the 4 plus ax cubed plus ax squared. And then for the next term, we're going to FOIL that out. We're going to get bx cubed plus bx squared plus bx. And for the next term, we're going to get cx squared plus cx plus c. And then for the last term, we're going to get dx to the 4 plus ex cubed. Okay, now let's group all the powers of x together. We're going to have an x to the 4 term. So a is one of them, has that. We'll cross it out as we go. And there's a d. D. So those are all the x to the 4 terms. Now we have to worry about the x cubed terms. There's an a, and then plus a b, and plus an e. That one's gone. Now worry about the x squared terms. We're going to have an a from there, plus a b from there, plus a c from there. Those are done. And now we have the linear terms. X, let's see, we have a b and plus c. And then we have a single constant plus c. It's all by itself. Now, if left-hand side is equal to right-hand side for all values of x, then the coefficient in front of each power must be the same. That means the coefficient in front of x to the 4, we'll do that separately. On the left, we have 0 times x to the 4, so we're going to have 0 equals a plus d. For the x cubed term, we also have a 0 on the left. 0 is going to be equal to a plus b plus e. For the x squared term, we also have 0, so 0 is equal to a plus b plus c. And then for the x term, we don't have 0, we have 1 in front of x here. So 1 equals b plus c. And then for the linear term, constant, we're going to have 1 equals c. So that last one tells us that c is equal to 1. Then we can plug that into the one above. So now the one above says 1 is equal to b plus 1. That means b is equal to 0. Okay. Now we can plug that into the previous one. We have 0 equals a, which we don't know, plus b, which is 0, plus c, which is 1. That means a is equal to negative 1. So we have that one. So now sub that one back into the one above. We have 0 equals a, which is negative 1, plus b, which is 0, plus e, which is unknown. We can solve for e now. E equals positive 1. And the last one, which we have to do, is plug in a. So we found a is negative 1 plus d, and that means d equals 1. So we solve that one. So the question was asking, find the values of b and d. So that's this one here, this one here. So we have b equals 0, d equals 1. And going through the choices, b is equal to 0, d is equal to negative 1. Nope, not that one. B is equal to 2, nope. B is equal to 2, nope. B is equal to 0, yes. D is equal to 0, no. So the answer is E, and the above. Aggravating to pick, but sometimes you have to pick it. Okay, next. Third question. integral from 0 to 4 of dx over square root of x squared minus 8x plus 20. Okay, this one is an inverse trig substitution, but first you have to complete the square. So we'll write this as integral from 0 to 4 dx over square root of x minus 4 squared. And then if you FOIL this out, you're going to get x squared minus 8x, so those first two terms will match, and then you get a plus 16. But you want a plus 20, so you have to add an extra 4 to it. Okay, now it's ready for one of two things. You can either do an initial substitution, let t equal x minus 4. You can do that, that's fine. Or you can do an inverse trig substitution all at once. So I'm going to let x minus 4 equal the root of this term that's all by itself, 2. And because this is a plus sign here, it's tan of theta. That means dx equals 2 secant squared theta d theta. And we could fix the bounds of integration right now if you want, but I'll skip that. I'll just write it as integral from a to b. dx gets replaced by 2 secant squared theta d theta. On the bottom we have square root of x minus 4 got replaced by 2 tan theta. So we have 2 tan theta all squared. 4 tan squared theta plus 4. And then we use this identity. 4 tan squared theta plus 4 equals 4 times tan squared theta plus 1, which is 4 times secant squared theta. And then the square root, take the square root of all that, square root, take the square root, you get 2 times the secant of theta. So you have the integral from a to b, now 2 secant squared theta d theta divided by 2 secant theta, secant theta. So the 2's are going to cancel. 1 power of secant will cancel on top, and 1 on the bottom is completely gone. So we have the integral from a to b of secant theta d theta. And that's one of the ones that you should memorize, otherwise you're left using the trick, the multiplication by 1 trick, which is not very fun. So this is equal to the ln of the absolute value of the secant of theta plus the tan of theta, evaluated from a to b. Now we have to redo or undo the triangle stuff. So according to what's up top, we can isolate for tan theta equals x minus 4 over 2. So we can replace that down here. Now we need secant of theta. So I'll draw a triangle. Here's theta. I'll call that theta. Tan is opposite over adjacent. So x minus 4 goes here, 2 goes here. We can use Pythagorean theorem to find this side, which is going to be x squared minus 8x plus 20. It's always going to be that. Missing side is always going to be that thing that we started with, but you can confirm that if you want. Square both sides, add them together, and take the root. And now we want secant of theta. So cos of theta is adjacent over hypotenuse, and that means secant of theta, which is 1 over cos, will be hypotenuse over adjacent. And then that's going to be square root of the mess, x squared minus 8x plus 20, all divided by the adjacent, which is 2. Now we can sub those in up here. We have ln absolute value of the mess, x squared minus 8x plus 20 all over 2 plus x minus 4 over 2. evaluated from, now we've put it back in terms of x, so we can use our old bounds of integration now, integrated from 0 to 4. It's slightly easier to change the bounds and not have to undo all this triangle stuff, but I don't think it's as popular. Okay, now let's sub in the number. Sub in the top bound, subtract the bottom bound. We sub in the top bound, sub 4 into the top, we're going to get 16 minus 32. Let's do 36. Well, let's see, 16 minus 32 plus 20. So 30, we're going to get 4 up top. So we're going to have root 4 over 2 plus 0. Sub in 4 up here, we're going to get 0. That's the top bound, the minus function evaluate the bottom bound. We plug 0 in, we're going to get root 20 over 2, and then minus 1/2. No, sorry, minus 2, minus 4 over 2. What am I doing? There. Okay, this first part is going to be ln of 1. Drop the absolute values, all that stuff, and there's positive. The second one, we're going to have ln of absolute value root 20. We can write as the root of 4 times 5, which we can write as root of 4 times root of 5, which is 2 root 5. We have a 2 in the denominator, 2 up here, so those will cancel, just left the root 5 minus 2. So values. Ln of 1 is 0, so we're going to have negative ln of root 5 minus 2, which is a wonderful perfect answer, except it's not there. But doesn't mean it's wrong. Doesn't mean it's none of the above. So to make it match, we're going to play some log tricks. This is equal to the ln of, well, this stuff in here is positive. We can drop the absolute values because root 5 is larger than 2. We're going to have root 5 minus 2 all to the negative 1. You take the negative 1 that's in the front, negative 1 times the ln, bring it up as a power. And then we can write that as the ln of 1 over root 5 minus 2. And then we'll conjugate. We'll multiply by 1. Multiply by root 5 plus 2 over root 5 plus 2. We'll have the ln of root 5 plus 2 on top, and on the bottom of root 5 times root 5, which is 5. The cross terms will cancel. I'll have negative 2 times positive 2 minus 4, giving us a wonderful, beautiful answer, ln of root 5 plus 2, which is choice A, root 5 plus 2. Yes, I know, I picked B. I think that existed on OWL for a few hours. Picked this one, which was incorrect. Next question, number 4. Improper integral. So start by writing it the formal, careful way. So that integral equals the limit as t approaches infinity of the integral from 1 to t of 10x over 5x squared minus 1 minus 6x over 3x squared plus 1. Okay, now you can do each of these integrals using a substitution. This one, you'd let u equal 5x squared minus 1, and then du is equal to 10x dx. So then dx is equal to du over 10x. And then for the other one, you'd let w equal 3x squared plus 1. So dw is equal to 6x dx. So dx is equal to dw divided by 6x. You can go through all the arithmetic. You'll get 1 over u here minus 1 over w here, and then this will be 1 over u du minus 1 over w dw. Integrate it out. You're going to get a ln of absolute value of u, which is ln absolute value of 5x squared minus 1, and then ln of w, so ln of absolute value of 3x squared plus 1, evaluated from 1 to t. So I just kind of did this in my head. Okay, now let's plug in the bounds. We still have that limit that haunts us until we sub in all the bounds and simplify. Ln absolute value of 5t squared minus 1. Sub in the top bound minus ln, I'll sub in the bottom bound. We'll have ln absolute value of 5 times 1, which is 5 minus 1, so we have ln absolute value of 4. Let's drop the absolute value silliness because it's positive. And then for the second function, the second part of the function, we have minus ln absolute value of 3t squared plus 1. And now plus ln of, plug 1 in, we get 3 plus 1, we get ln 4. Okay, minus ln 4 plus ln 4, those are going to cancel. So we have limit as t approaches infinity of ln absolute value of 5t squared minus 1 minus ln absolute value of 3t squared plus 1. Okay, this is an indeterminate form. It's infinity minus infinity. If we try to take the limit, so we'll use log properties to combine them. We have ln of a minus ln of b. We can write that as ln of a divided by b. So limit as t approaches infinity of the ln of absolute value of 5t squared minus 1 divided by 3t squared plus 1. Okay, we can bring the limit inside the ln. This is infinity over infinity. You can either divide top and bottom by t squared and then use limit laws, or you can use L'Hopital's rule twice. And either way you do it, you're going to get ln 5 over 3 as your answer, which fortunately is one of the choices. Choice A. Okay, next question. Number 5. It's a concept question. It says the partial sum, S sub n, equals the sum from k equals 1 to n of a sub k. That's the definition of a partial sum. It's the first n values of a sub k added up. So a1 plus a2 plus a3 all the way up to an. And if you add them up to the nth one, it tells you that that partial sum formula is n over 2n plus 1. And it wants to know which of the following statements is true. So it's saying S sub n equals n over 2n plus 1. And then the sum from, this is what you're more familiar with, the sum from n equals 1 to infinity of a to the n is defined as the limit as n goes to infinity of S sub n. If you add up an infinite number of a sub n's instead of just n of them. So we can do that. That's the limit as n approaches infinity of n over 2n plus 1. It's a rare luxury to be able to calculate explicitly a partial sum. Okay, this is infinity over infinity. You can use L'Hopital's rule, or you can divide top and bottom by the highest power of n and the bottom, so divide top and bottom by n. Either way, you're going to get 1/2 out of this. And that means this sum converges to 1/2. So it's definitely not a. It can't be a. Sum converges. So sum over a sub n converges. No. Sum over a sub n does not equal 0. We just found it's equal to 1/2. So it can't be b either. A sub n is equal to 1 over 4n squared plus 1. We have to do some work to tell if that's correct or incorrect. The general form for doing that is we can calculate a sub n is equal to s sub n minus s sub n minus 1. So conceptually what's going on is this. Suppose S sub n represents the first 50 paychecks that have been added into a bank account. And you want to find out how much money was added in for that 50th 50th week or 50th time, what you could do is, if all you were given was a formula for how much money is in that account as a function of number of weeks, you could take the money at week 50, subtract the money that's in there at week 49, and that would tell you how much money was added in that week. So that's what we're doing here. We're saying how much, this A sub n is how much money was added for week n, and it's equal to what that difference is from week n minus 1. So to calculate that out, S sub n is given to us, n over 2n plus 1. And S sub n minus 1 we get by replacing every instance of n with n minus 1. So we have n minus 1 over 2 times n minus 1 plus 1. So we have to do some FOIL, do some fun stuff. Minus n minus 1. Keep in mind there's a bracket there. We're going to get 2n minus 2 plus 1. This is going to be n over 2n plus 1. So we have 2n minus 1 there. Now let's bring them to a common denominator. So let's cross multiply. We'll have n times 2n minus 1 minus n minus 1 times 2n plus 1, all divided by 2n plus 1 times 2n minus 1. So we have 2n squared minus n minus n times 2n, so 2n squared, n times 1, so minus n, minus 1 times 2n, there's already a minus in front, so plus 2n, and then 1 times negative 1, with a negative in front, so plus 1, all divided by 2n times 2n, so 4n squared. We get cross terms will cancel, and we'll get minus 1. Already we can tell that it's not the same because the denominator is different. Let's just keep going and simplify it. 2n squares will cancel. We have a negative n, and a positive 2n. Those will all cancel. So we're left with 1 over 4n squared minus 1. So this one's wrong. It's off by that sign, by that negative sign in the bottom. Last one. Limit as n approaches infinity of a sub n is equal to 0. That's definitely true. Let me explain why. If the sum of a sub n converges, it means that the nth term, when n becomes very large, must go to 0. If it didn't go to 0, the sum wouldn't converge. It would fail the divergence test. So we need limit as n goes to infinity of a sub n must be 0, or it won't converge at all. So that's why it's choice D. Okay, next question. Which of the following series converges conditionally? So I'm not going to go through all the proofs of each of these. It's too time consuming. Instead, I'll give you some shortcuts for determining very quickly if a series converges or diverges. In a long answer part of a test, you'd have to show, with a ratio test or comparison test or limit comparison test or an integral test or whatnot. But for multiple choice, you can just use kind of shortcuts. So minus 3 to the negative n over 2 to the negative n. Let's absorb that minus sign on the exponent to reciprocate. So this is going to be 2 to the positive n over negative 3 to the positive n. And that's going to be 2 to the n over negative 1 to the n times 3 to the n. And having a negative 1 to the n on the bottom is the same as having it on top. This is just going to be plus or minus 1, doesn't matter if it's on top or on the bottom. And then we're going to have 2 over 3 all to the n. That's a geometric series. So even ignoring this, even ignoring that negative 1 to the n, 2 over 3 to the n is going to converge. Negative 1 to the n makes it converge even faster. So it doesn't converge conditionally. It doesn't need the negative 1 over n to converge. So it's not A. It converges without it, without the enhancement. Second one. So we have negative 1 to the n times square root of n plus 2, not inside the square root, all divided by n plus 1. Okay, let's for a moment ignore the negative 1 to the n. Let's see if this series needs it to converge. As n becomes large, This plus 2 is insignificant. This plus 1 is insignificant. This is going to look like, so ignoring the negative 1 at the end, this is going to look like root n over n. And that's equal to 1 over root n. N to the 1/2 over n to the 1. Subtract the powers, so you have 1 over root n. And that equals 1 over n to the 1/2, which is p series with p less than 1, which means it diverges. Now, what happens if you add the negative 1 to the end? Negative 1 to the end. And then if you tack it onto this, over n to the 1/2, so that's a new series. Let's apply the AST to it. Well, this is obviously decreasing as n becomes large. The magnitude of the absolute value is decreasing as n becomes large. You're taking 1 over ever larger numbers. If you wanted to prove it, you'd have to do the calculus thing, take the derivative, but this is a multiple choice, so you don't have to do that. You just tell by looking at it. AST requires that the limit, as n approaches infinity, of the absolute value of our function, of our summand, has to be 0. So we have a limit as n approaches infinity of 1 over root n. That is 1 over infinity, root infinity, which is 0. So it passes the alternating series test, which means it is conditionally convergent. This is true. So I'll put a check beside it. And look at the other ones. For C, C goes as root n plus 2 over n cubed plus n plus 1. When n becomes large, this is going to look like the 2 doesn't matter. This n compared to n cubed is insignificant. N cubed is going to be the dominant term. Okay, and then we can use exponent laws to write this as, well, this would not let me do that, it's equals n to the 1/2 n cubed. That's going to be 1 over n to the, well, n, so 6 over 2, so 5 over 2. And that's a p series with p larger than 1, so it converges. Absolutely. So it's not this one. It converges absolutely, not conditionally. This function down here, for D, it's going to go as n over the root of n squared, which is equal to n over n, which is equal to 1. It's going to fail divergence test. And you could do that explicitly. And it's also going to fail the alternating series test. So it doesn't converge, not even conditionally. So choice B. Next question. Which of the following series converges absolutely? Let's look at choice. So absolutely means we can just ignore all those negative 1 to the n's. If they're necessary to make the series converge, it doesn't matter, because we need them to converge without them. So the first one, for A, the series is going to go as the most powerful